Hello and welcome back. I'm Atif and you are watching Base2's Fast API Async IO Foundation course. Today we will begin working hands-on with Python's built-in Async IO library. Async IO is part of the standard library, so you don't need to install it as a separate dependency or requirement in your project. Now let's quickly take a look at async await syntax. This function here looks like a regular Python function, and we want to convert it into a coroutine or an asynchronous function. To do that, we have to do a couple of changes. Number one, we have to add async keyword to the function header. And yeah, this async def indicates that it is an asynchronous Python function. Second thing that we need to do is within the function body, whenever we call a non-blocking function or a coroutine, we have to use a wait keyword. This is async IO modules sleep function. This is different from time.sleep. You can see here that this sleep function is an async def function, and which means it is a coroutine. So whenever we have a coroutine, we have to await it. And what does it mean? It means that if we don't have await, this function call will only create a coroutine object. It will not actually execute the function unless we have awaited it. So we have to use await keyword with every coroutine call. The third change that we have to make is not really a syntax change, but a change in the flow of program. So our regular Python programs, we can start their execution by simply calling our main routine or the main function that we have, which is in our case greet function. But in case of async IO, we have to use async IO modules run function as the entry point of our program, and we have to pass the greet function into the run function as its parameter. So the run function will create an event loop for our program, and it will schedule the greet function to be executed by the event loop. So these are the three changes: async keyword, await keyword for the async def function calls, and the entry point of asynchronous programs, which is async IO run function. Next, we are going to see an asynchronous program in action. We will compare the performance of the asynchronous program with an equivalent synchronous program. To do that, let's start with this one. I have created a synchronous version already. So we are defining a long task here. It takes the task ID as parameter so that we can create multiple tasks with the same function and monitor the progress with the task ID. This function simulates a long-running blocking task with the time.sleep function. Time.sleep, is a blocking function, and it not only blocks the execution of long task function itself, rather it blocks the whole thread, and nothing in our program executes for those 2 seconds of sleep. In the main function, we are creating 4 tasks using the same function and different IDs. At the start, we mark the start time, and we also mark the end time, and then we print the total execution time for our program. Now, let's take this same code and paste it here. We will convert this program into an asynchronous version. You know that we have to use async keyword in this function header. We need to use async here as well. Now this function is an asynchronous function. We also call it coroutine. Next change we need is here. This call now needs to be a non-blocking call, and as you saw before, we have async IO module, and it provides us a sleep function version which is non-blocking. So we need to import async IO, and then in the main function we have to use asyncio.gather to run the coroutines concurrently. Long task 1, long task 2, 3, and 4. So we are running 4 coroutines concurrently using gather function, and we are marking the start and end time. Let me change this log message here as well for better tracking of our programs. And the last change that we need to make is we have to do asyncio.run, which will be our entry point, and we have to pass the main function in here. We are missing something here. We have to await the coroutines, and gather function is also a coroutine. We have to await it as well. So this is all that we need to change. Now let's start with a single task and see how both functions perform. Let's execute the synchronous version first. Synchronous. So the program took 2 seconds to execute as expected. Now let's execute the synchronous version again with 1 task, and it also took 2 seconds. So where is the benefit? As you know, async IO is for concurrency. Right now we have only 1 task, so there is no apparent benefit of using async IO. Now let's have additional task. So we have now 2 tasks in both of the files. I will execute first async version again. So you see that task 1 completed and then task 2 started. So overall time is 4 seconds. Now let's see a synchronous version. So both of the tasks started and completed within 2 seconds. So the performance improvement we see already. Let's do one more exercise and add 2 more tasks, 3 and 4. Do the same in sync version, 3 and 4, and execute the sync version first. You see that 1 task completes and then the next one starts, and the overall time is number of tasks multiplied by 2 seconds of wait time for each task. So 8 seconds it took, and let's see what does async do in this case, all four tasks started concurrently and completed within 2 seconds. So as the number of tasks increase, we can see that the benefit of async IO is more visible.